The more you explore, the more you learn and grow. Good morning, my name is Niten Gurung, student of Namche Government College, bearing roll number 20NS0419. First of all, I'd like to thank Dr. CP Sir for giving me such a wonderful opportunity to explore, learn and grow. I would also like to thank Sikkim University, Namche Government College and Department of Physics for giving me such a golden opportunity. Introduction. A transistor is a three-terminal semiconductor device that amplifies or switches the flow of current. Or a transistor is an electronic device that controls the current flow or switches the current flow. Or a transistor is an electronic device that controls the movement of electrons. In simple words, we can say that it's a semiconductor device used to amplify or switch electronic signals and electrical power. CE configuration of a transistor. When a transistor is connected in a common emitter configuration, the input signal is injected between the base and the emitter, which is a low resistance, low current circuit. As the input signal swings positive, it also causes the base to swing positive with respect to the emitter, which means this type of biasing arrangement uses two resistors as a potential divider network across the supply, with their central point supplying the required base bias voltage to the transistor. Theory of the common emitter output characteristics. The output characteristics of common emitter is the curve between collector current IC and collector to emitter voltage VCE at constant base current IB, which means is basically describe the relationship between output current IC and the output voltage VCE. Using these characteristics, we can determine the output resistance, which is equal to change in collector to emitter voltage divided by change in collector current. While drawing these characteristics, we have considered NPN transistor. As you can see here, we have three regions. One, saturation region, number 2, active region, and number 3, cutoff region. Number 1, saturation region. Part of characteristics curve lying between origin and knee of the curve is known as saturation region. It's between the origin, characteristic origin, and the knees of the curve. These all are the knees of the curves, for which the constant are there. Between this origin and this knees are called saturation region. This blue region is showing the saturation region. In this region, both collector and emitter junctions are forward biased. Second, we have active region, which is the horizontal part of the characteristic curve. In this region, collector junction is reverse biased and emitter junction is forward biased. Third, we have cutoff region. The part of characteristic curve where IB is equal to 0 is known as cutoff region. When we take base current is equal to 0 microampere. Area under this curve is known as cutoff mode. In this region, both collector and emitter junction are reversed biased. Calculation and result. Now, when we do the graphical representation, taking output voltage VCE in x-axis and output current IC in y-axis, we get the graphical relation between the two, keeping IB is equal to constant. Now we know collector current IC is equal to beta IB plus beta plus 1 ICBO. When the base current IB is equal to 0, IC, that is the collector current, is equal to beta plus 1 ICBO, which is known as the leakage current. The above equation IC is equal to beta IB plus beta plus 1 ICBO is independent of the output voltage and clearly depends on the input current and the leakage current. When we draw the curve taking the different values of the base current IB, keeping them constant, we get graph like this, which is nothing but the output characteristics of transistor in CE configuration for the different values of the base current. When the base current is equal to 0, it's nothing but the leakage current. When the base current is equal to 0.1 microampere, collector current is 5 microampere. When the base current is equal to 0.2 microampere, collector current is 10 microampere, and so on. Now for the AC current gain, the base current is 0.1 microampere, collector current is 5 microampere. When the base current is 0.2 microampere, the collector current is 10 microampere. So the AC current gain is equal to 10 minus 5 by 0.2 minus 0.1, which is equal to 50 for this output characteristic. Now we know VCE is equal to VCB plus VBB, and we know according to the early effect When VCE is increased, then VCB is also increased, which affects the width of the base, leading to decrease of the base current. When the base current is decreased, collector current is increased. So the collector current is not only dependent on the input current IB, but it also depends on the output voltage VCE. Conclusion: in CE configuration, the curve draws between collector current IC and collector emitter voltage VCE at a constant base current IB, which is called the output characteristics. There is not a single conclusion from the output characteristics of BJT. We can get the saturation value of the collector current IC with increasing voltage for different base current IB, and we can also note variations of the maximum saturation value of a collector current for the change in the constant base current. Advantages of CE amplifier: number 1, a common emitter amplifier is inverting and has low input. Number 2, high output impedance. Number 3, high voltage gain. Number 4, high current gain. Disadvantages of CE amplifier: number 1, it has a high output resistance. Number 2, it responds poorly to high frequencies. Number 3, it has high thermal instabilities. Number 4, its voltage gain is very unstable. Moving on to the applications, we have number 1, the common emitter amplifiers are used in the low frequency voltage amplifiers. Number 2, these amplifiers are used typically in the RF circuits. Number 3, in general, the amplifiers are used in the low noise amplifiers. With this, I have come to the end of my presentation. Hope you all like it. Thank you.